Hello, welcome to Masculine Learning and Masky TV Grade 12s. I am very sure that today when you're sitting here, just wondering why are we doing maths tonight. I know that you were busy writing your paper 2 of physical sciences, economics, as well as technical sciences, right? So you wrote that, and I'm very sure that you're saying that I didn't do well. But anyway, we still have to go on, and in this case, when we are cracking this maths, we will have to look at what we need to do for writing final examination or prepare ourselves enough to write final examination. I do have a secret for you guys. Today, Masculine Learning just launched Crack the Maths Code. Do you see this book? It's your solution. It will make sure that your final examination does not trouble you as your trial examination did. So please get yourself a copy. It's actually very affordable, rather online or offline into stores. You can buy and have a very nice copy for yourself. It's a fully colored, coded, and make sure that it explains every single thing that you need with the errors and misconceptions, QR codes of your videos. Your tutor mask is in here embedded for you to make sure that you get it right at the beginning. So please don't stay away. Make sure that you get all this which we have brought for you from MML, the home of platinum. Make sure that you are one of the people that get it right. So let's get into this as we refresh and relax. All right. First of all, when you are dealing with any question or any topic which is inside the Crack the Maths Code and it is done in this format, so you will check what it is that I need to know and how am I going to do it, right? So here we are saying that we need to be able to first know what is the error that I can make for this chapter, because at this point, you guys have studied, have done all the topics that you need to do, but you still have errors that you have seen happening. You also see some from your personal trial examination. You must check those errors, and then you use the questions like what we are saying here. Practice responding using exam questions to try and make sure that you don't repeat the same errors. You must do many questions and always check back to say, did I manage to fix this error? Did I manage to solve this misconception? If yes, we're good to go. Always remember one thing, that the small thing that you do will take away the marks. For functions, the success really links with your algebraic equations and how you deal with the graphs. So the way of you thinking about algebra link or work hand in hand with functions. So make sure that you do that. All right. Then the errors and misconceptions that we have used now here, over and above the one that you'll find in Crack the Maths Code, is the one that are taken from the diagnostic report of 2024. The learners were confused when they deal with the domain and range. Some don't even know what is the meaning of domain. I always say, when you say domain, just say all possible values of X, and that is how you describe domain. And range is all possible values of Y. So that is how you describe range. But you remember, when you talk about domain and range, should be where the graph will be, not the places where the graph cannot touch or cannot reach. Okay. Some are forgetting the asymptotes as well as the restrictions that need to be used or are there. For example, if you are given y equals 1 divided by x, you need to always remember the restriction here that says that x can never be equals to 0. Why? Because if x is 0, then we have undefined. Right. So those are the restrictions that you always have to remember, as well as the asymptote, which we will do as we go from one graph to another. Right. Learners also struggle to sketch the graph properly, labeling their intercept as well as the turning point if there's any, and that goes as well as asymptotes as well, right? So making errors like this when you're solving this, it is not a good thing. Others do errors of solving equations, and these are not just mistakes. it's something that can cost you marks, because normally when you have a question, it literally continues from 4.1, 4.2, or 4.1.1, 0.1.2, like that and like that. So it's a continuous kind of question. So you need to make sure that you gain all the marks that you need for you to survive in examinations. All right. So we're not going to waste time. You guys are very waiting for this. So let's work together. I've decided to use the diagnostic report errors of 2024 and also the question paper that was used for 2024, so that we can work alongside of those diagnostic errors. All right. So the first thing we have here, you can see they are saying that we are given. So always what I do is I analyze what I have and I roughly remember what it is that I have in my plan. So here we are given an equation of like f of x equals a to the exponent x minus 1. So immediately when I have this, I know that it's an exponent equation which has to look like that, or the exponent graph which have to look like that, or to look other way around. So it's either going this way or it goes that way. So that is how I describe my exponent. Immediately when I see it, I just remember to just do that and say that is how my exponent can look like. Either one of this is the shape that I need, right? But they gave us a restriction and said that a must be greater than 0. They only just say that a must be positive. So we have to make sure that our a is positive. It doesn't matter if it's a fraction or not, but it has to be positive. And they gave us a b value, or a b coordinates, with x being 2 and y being negative 5 divided by 9. And the first question, they say calculate the value of a. So now how do we calculate the value of a? Let's do it together. So 4.1, they want us to calculate the value of a. We know that we are given f of x equals a to the exponent x minus 1, where f of x represent y. So if you forget, just always say y equals a to the exponent x minus 1, right? The coordinates that we are going to use here is the coordinates of b, which is given to be 2 and a negative 5 and 9. So we're going to use that, substitute it, and then we get what we want. Remember we said that 2 represent x, and then negative 5 divided by 9 represent y. So wherever you see x, you're going to substitute it by 2, and wherever you see the y, you're going to use negative 5 divided by 9. So let's do that. Our y will be negative 5 divided by 9. That is equal to our a is what we are looking for, and while 2 is the x minus 1, right? Then we can do what we have to do in this case. We need to subtract a 1 or add 1 both sides for us to make sure that on one side we only have a. So I'm going to add 1 here and as well as add 1 there, right? When I add the 1 in both sides, you can see that on my right hand side, I'm going just to remain with a squared. Then you can quickly use your calculator. With the other one, you can see that negative 5 divided by 9. So negative 5 divided by 9 plus 1. That's what we have. That is giving me 4 divided by 9, which is a positive, right? As soon as you have this, you just have to remember that you are looking for only a, and for you to get that, you need to put square root on both sides. So if I put square root on both sides like that, remember every time you put square root, there is a plus or minus that need to be put, because a square root represents both of them, right? Then when I do that, the square on the side, it will be removed by the square root. Then I remain with the a. And then on my left-hand side, I have then a square root of 4 divided by 9, which is the same as 2 divided by 3. Plus or minus, but because they told me that my a must be positive, this is my guide. Since they told me that a must be positive, that means that I am going to only focus on that a being positive. So this is my value of a, and in this case, I would have got my 2 marks. Right. Where do we get the 2 marks? 1 mark will be for substitution of what I have, and then the other mark will then be for the answer. So that is how they will give me my 2 marks, and voila, we got the value of A. Please pay attention to the fact that this is usually a scaffolded questions which follows each other. So whatever you do at one point, you need to be able to go back and do on the others. So immediately I have my value of A like that. I can actually just come somewhere on my rough space and put the whole equation so that I can remember it. My whole equation is actually f of x equals to, now I have A, so I'm going to use 2 divided by 3 as my A, but it has the exponent of x, then minus 1. So I'm putting it there for in case I need to use it somewhere. Right. Then they come and say, write down the range of f. Now you need to write the range of f. If I was to draw the diagram or I was to find the y-intercept, for me to find the range, it might be that I need to find or know what is the y-intercept or what is the value of y that the graph will have. So all the time when you have the equation like this, which is an exponent, this is always your asymptote, because it's the side that, or is the point whereby your graph will never touch. So if I just make sure that I am looking for that point of an asymptote, which my y then will be equals to -1, that means I can use that to get to my range. Remember, range is all the possible values of y that I can get, all the possible values of y that I can get. So therefore that means my range have to be anything that is above, because my shape therefore would have been looking like either this way, like that, or it has been looking like either that way, the other way around. So we went this way, we can go this way. So it's either this way or that way. So this is the 2 shapes that I can anticipate for both my values. And that means that if I have an asymptote which will come somewhere here, which will be by y equals -1 in both in scenarios where y equals -1, that means that my graph will just pass somewhere here, which means that y would never be -1. So that's where you take it from, and then you respond when they ask you about range. So that means that y therefore cannot be 1, but any value that is more than that -1 is what we need to be the range. So then we can write in this format, or we can use the format of open brackets where we say from here to somewhere else. So we can say, or you can write, but you have to write only one, right? So we are saying that y cannot be -1, right? But it can also not be what? So that is where y is. Let's put our y inside. Let's put our y there. So y is an element of, that is how you're going to write it, -1, and then the other one, because the graph is going up to where we don't know, that is going to be a positive infinity. So it's starting from a -1 and it goes up, up, up until it reaches the positive infinity. So these are the 2 formats that you can use to write the solution. But I always just write one and move on, and you don't have to write both, you have to write one. All right. Then the next question, they said now, sketch the graph of f, clearly show the intercept, which is what they say other people are struggling to get, and also show the asymptotes, right? So that's what we need to do. We need to draw our graph and make sure that we can show those 2. So let's quickly do that and see how we can do. Yours will have to be clean and straight, because you are using the ruler to answer this, or you are using the ruler to solve this, while I am not. So let's see how we're going to do this. Always label your Cartesian plane. X and y is very important. Now, the one thing that you need to remember is that every time you have to draw the graph, you need to find the intercept. It's very important to just first find your x-intercept, which at this point we were not asked to find, but we can always find it. Remember, our equation, our graph is y equals to A, we found it as 2 divided by 3, and that has as an exponent of x, and then it's minus 1. So if I'm looking for, suppose y-intercept, I just have to remember that x must be 0. So I just have to put 0 where I have it here. So you can see when I put 0 as the exponent, then that means I'm going to have 1, because everything that is have a power or an exponent of 0 equals 1. So when I do that, that means I'm going to have y equals 2 divided by 3 to the exponent 0 minus 1, which lead me to 1 minus 1, and that means I have 0. So which means that my coordinates therefore will be 0 and 0. That is my y-intercept coordinates. I can do the same for my x coordinates of the intercept. So for that, I'll also do the same. I have y equals 2 divided by 3 to the exponent x minus 1, right? Because I'm looking for x, I am going to let y to be 0. So for x-intercept, we let y to be equals to 0. So when I substitute there, I'll have my 0 equals 2 divided by 3 and to the exponent x minus 1. Then I can move the 1 from my right to the left. So if I come and add 1 both sides, that means I'm going to have 1 on the left, which will be equals to 2 divided by 3 to the exponent x, like that. But one thing that you have to remember is that if I can just find the point which I can use that can give me 1, is just a trial and error, which some don't even realize. There you just have to change this one to be in an exponential form, which is 2 divided by 3. But instead of you writing it as 2 divided by 3 like that, it has to have an exponent of 0, which is the same as 1. So if you do that, that means you are now able to deal with your exponential functions, because when we have the same base, we just drop the exponent. So therefore, your x is also equals to 0. So you see, all this is just telling you that when I draw this graph, I can actually do it this way and get my x and my y to be 0. Or you can then draw the original graph and drop it down, right? Transformation. So how do you do that? You just remember that in here, your original graph will have been y equals 2 divided by 3 to the exponent x. And when you have that, you just know that your graph will therefore, as saying that as x increases, y is actually going to decrease. So every time you put 1 here, you're going to get a value that makes y a very small value all the time as you go on and on. And that graph will look like something like this. So the normal equation or the normal graph that we have, we can just quickly try and draw it and see if we can. So suppose we have it like that, which is not up to scale, and this will be my 1, right? So this is my 1. And if I drop it down, 1 unit down, according to what they said here. So if you check what I have highlighted for us here, look at this. This simple means that my equation that I had there, it has been dropped down by 1, which means we have a minus 1, which is what is given there. So every time you see that, what you do is you move everything you have 1 unit down, because it's minus 1. But before you do that, remember there's an asymptote. So this was our original asymptote for our original equation before the shift. Remember, this line is called y equals 0 line. So by the time I come and I have y equals minus 1, that means it has dropped 1 unit down. So what I will do is I can first just draw my line, which is the drop down. You can see there, my green line has been drawn down just 1 unit down, as much as I will drop my graph from where it is to somewhere else. So if I drop this graph, it will come here. Let me try to draw it. It should come here, since we said x and y is 0, and then we come there like that. So this is how your graph will have dropped 1 unit down and then leave the asymptote like that. Every time you do this, try to make the yellowish one to be like a very light so that nobody can see that, and then you just use it to drop down. So there's 2 ways for you to draw this graph. 1, find your x and your y intercept, and then you use your point, which is this one, and then in this case you can come and use this point that you had for 2 and a -5 divided by 9, which can be somewhere here. So you can come and use your point B as well, and then you just connect it, you draw the graph, or you can find another one as well on the second quadrant, and then you just make sure that you draw it up there. So you can use a transformation to get the graph, or you can actually just drop your graph in that manner for it to look more or less like this. All right. So that is how you deal with the graphs, and this is how we get into the solution. So what I like about the graphs is whatever you do have a mark for it. So the fact that you have went on and find your point of intercept, which is the 0 and 0, you will have a mark for that, and also for the fact that you have your asymptote correctly, you would have a mark. The other mark we would then give you for getting the correct shape, which is the crescent kind of a shape. Then you give you the full marks like that. All right. Now they said if it is further now given that C is a point of f at y equals 19 divided by 8. So now they're saying the graph that you have now have a point called C. Before you can even do anything, you can just go back and say, I have my f of x. You can just go back and you say, I have my f of x, which is equal to, remember, 2 divided by 3 to the exponent x minus 1. That is our full equation. So they are saying that there's a point called C, but that point then have y value as 19 divided by 8. So what you're going to do then is to substitute your y value. Remember I said f of x is the same as y. So what you're going to do there, you're going to just say this is a 19 divided by 8, and then you work out the x value for you to first find the point C, because they've given you that. So this is equals to x, that is equals to, let's start there. I'm already solving for x. So that is 2 divided by 3 to the exponent x minus 1. But then we need to remove the 1. How do we move it? We're going to add 1 in both sides so that we can remain with the exponent that can help us. So we can add 1 in both sides in this manner. Let's add 1 here so that we can see it properly. Then we can then know that on our right-hand side, we only have this part, and the minus 1 plus 1 is now 0. So that is going to be 2 divided by 3 to the exponent x equals to, then we can quickly get the other one, that is 19 divided by 8, and then we add the 1 there. That gives us 27 divided by the 8, right? That is what we are getting on the other side. So what we can do here to try and get it in the best way, there's many ways for us to get to the answer. One can be, we first just find the same number that we can put at the top, and then we get that, or we can literally just use log, since you guys are now in grade 12 and can do both of this. So there is many ways of solving this question. So you can actually change it to the point where you can get it having the exponent that, or the bases that are the same. So if I change that, 27, for example, it's the same as 3 to the exponent 3, and 8 is the same as 2 to the exponent 3. So if you look at it, you can see that we already have 3 and a 2 somewhere there, and then we can then be able to write that as 2 divided by 3 to the exponent x, and then we can then write our 3 divided by 2 to the exponent 3 equals 2 divided by 3, like that. Am I right? Okay, there we go. Then you write it like this, and then from there you can then be able to flip this one or swap it, whereby your exponent for 3 will become 1 divided by 3 instead. So you can have your answer then to be 2 divided by 3 and then to the exponent 1 divided by 3, which is the similar things, but you are just swapping it out. So the important part of this part of the question is that you can use a calculator, you can use logarithm when you reach this point, like here. You don't really have to go everywhere. You can just use your logarithm there, or you can use your calculator to get to the answer. But what is important is that you have managed to simplify or to substitute this part. So that is what they give you marks for, right? So this is one part where I was saying to you guys that you just have to first find your first part, which is your x value. So whenever you get your x value, then you can just use that x value to find your y value. So as I said, whatever method you can use here can help. You can either change on the right or on the left, but to give you the similar things, and then at the end of the day you'll be able to get your answer as it should be, right? So here you can see what they did is they have changed. They did not change the left hand side, but they change the right hand side because the right hand side have the x. So if you change your right hand side, you will see that it also gives you the similar thing, and then you get your answer then as a negative 3. So let's change it that way. If you change your right hand side, you're going to flip it the same way, but what is it that is happening is that your sign for x changes from the positive to negative, and you have 3 divided by 2 to the negative x, like that. Then as soon as you have that, you can then just drop your bases because they are the same. Then 3 will then be equals to negative x, and then when we divide both sides by a negative, then your x will therefore give you a negative 3. But this is the x value of C. So they said that C point have these values, that is negative 3, and then the other one that was given is 19 divided by 8. That was the y value. But the question itself, what they want us to literally find is to determine the coordinates of the inverse or the transformation of C. The point C which we have, it has been transformed, and they want you to find the image where there is a reflection, or C have reflected about y equals x line. That simple means when they say there's a reflection that happened where y equals x, that simple means that whatever that was x becomes y, and whatever that was y becomes x. So that means we're going to change what we had here as our x and y for it to be y and x, like that. So how do we change it? Then we're just going to write it as our C prime, which is like this. It's going to now then be 19 divided by 8, and then we have a negative 3. So we're just changing them because they have equal values. And that's how you actually respond to this kind of questions. And you can see that the marks are clearly shown where it's going. Your substitution is one of the places that they will always give marks for, and then they'll give you marks for the answer that you got there, and then they'll come and give you marks for the last part of the answer. It is actually quite a practice that you need to do, and that's why I always say that you need a lot of practice for you to be able to respond to this kind of questions. And it's actually nice, but it is doable. Please get yourself one of our most relevant textbooks that we have. I just added one on the list, which is Crack the Maths Code. We have our X Kit Archive, and we have Platinum Classroom Maths that you can get and get more questions on it. I think we have to do more questions, but I need you just to digest and get yourself together as you are adapting to what we have been doing. I'll see you after the break. Okay, grade 12, we're back again. Let's see what Maski TV is having for you. I'm very sure that you are busy telling your friend that they must subscribe because this is a channel not to be missed. So make sure that you invite them all to us and make sure that we understand and learn as we go. All right, so let's check the second question. That is still from the question paper of 2024 that other people have written as well, and you have seen it, I'm very sure. So let's see here. They said sketched below is a graph of f of x equals a. So you need to just know what this all means. This is our general formula, which represent a hyperbolic functions. It has a domain. They're saying it's coming from minus infinity up until 1, as well as from 1 to minus infinity. They're literally telling you that this graph will never touch 1. Initially, they told you that the graph at this domain, which the domain, remember, represent x, it will never touch 1. So they have told you what an asymptote is literally is. So they told you that is what it is. Even though they don't show, they've already told you them. The graph of f cut y-axis at x at where there's 0, at x equals to 0 and y equals 1. There's a line of symmetry which they've given us, which is g of x equals x minus 3. So when I look at this graph with all this information that I was being given, what I can just say is that this is x equals 1, and I can be able to find this one as well, but finding this one would have to start from here, for example. So as I start from there, I will then just make sure that this is 1 all along. So you can see the whole line here is going to be 1. And then we have the one here, which you can find at any case if you try and find x value where you in the g of x. So let's quickly do that. We have g of x equals x minus 3. So in that point, we already have the x value. What we are looking for is the y value. Remember, is this point we are talking about here. This point have x, but we don't know y. So we are looking for y on that point. So what we're going to do here is to substitute the x by 1. So that means, remember, g of x is y. So y will be equals to 1 minus 3, which gives us a minus 2. So that means that our other asymptote is basically y equals minus 2. So that is what you already have. Even though they don't ask you that question, you have already answered it in disguise by yourself without them telling you to do so. Just by analyzing the graph and the given information, it always helps you to get somewhere as you start with any question in math. Okay, now let's hit the ground. On the questions there, they say, write down the value of p. Now let's go back. Our value of p is actually starting at x. So I'm going to write this one down so we don't always have to look at it. F of x equals a divided by x plus p plus q. The value of p is actually the asymptote that x is. So there what we're going to do is just respond to the value of p. Basically, when we have x equals to 1, it's the same as when we write it like this. Let me show you here. If I say x equals 1 and then I go back to my 0 method, what I'm going to have is I'm going to have x minus 1 equals 0. So there at the denominator, or where we have x plus p, basically then the value of p will be my minus 1 like this, right? So when you answer that question, you just tell them that my p value will then be equals to minus 1. Because they didn't want you to write the equation of the asymptote, but they wanted you to just write the value of p. And the value of p by itself, since our equation have a plus p, it's actually minus 1. It does happen sometimes that they give you x minus p. So be very, very careful. Because when they do that, they're just tricking you to say, do you really understand what p is, or do you really understand what the asymptote is, right? So please make sure and pay attention to that. Okay, 5.2, they said determine the equation of the horizontal asymptote. The equation of the horizontal asymptote, this is our horizontal asymptote. We've already determined it, remember, on the other space. So we just say y equals minus 2. That is the equation. If I write y minus 2 equals to 0, that is still the equation, but that's not the format we write. So the equation we write as y equals something. So that is y equals minus 2, and we found it as we are analyzing. And when you analyze, make sure that you put it on the paper. Make it a rough paper, cloud it, whatsoever in your answer book. Make sure it's there so that nobody can lose it. All right. Then here, we now have to calculate the value of A. So calculating the value of A in this context, we already have the P value, we already have the Q value. So let's write it down. We have f of x equals to A, which is we don't know, x, which is at this point we also don't know, but it's minus 1. Remember the context we have put here, that should be x minus 1, then minus 2. So this is what we have, but we need to use a point whereby it is in the on the graph that can help us to substitute our y as well as our x for us to find the A, right? So that's what we need to do. So with that being said, you just look at the graph and see which point can I use. So there is a point here, but we don't know that point here for now. So I'm going to just do this. There is a point there which we don't know, but there is a point here which you already know, and it's given as 0 and 1. So if we substitute that point, we will be able to then find what we are looking for. So that is the way we solve this question. So we just have to substitute our y value as 1 and as 0 and as 1 and our x value as 0, like that. So let's try to do that. Or we can find our point here which we don't know, and then we'll find it. Because for us to find this point here, we literally just have to find the x-intercept. So if you find the x-intercept, you then can find the point that is there. All right. Okay, so that is the way for you to calculate the value of A. It's actually done in that manner. You can see here, I just want to try and show it for you quickly. Here you can see that we have substituted the point that I was showing you, or they've shown that the points have been substituted, as I've showed you that those are the points that you come and you substitute here and there. Okay. So let's substitute those points, and then you guys will be able to see what need to be done or how to get to the answer. So what point are we substituting? The given one, which is 0 and 1. Okay, so y then is 1, but then x is 0. And then we just substitute it like that, and then we solve for A. First move will be to move the minus 2 from the right to the left, so we can just add that minus 2 in both sides of the equations. Then when we do that, we're going to have 3 equals A divided by a negative 1, and then we can come and multiply both sides by a negative 1 for us to remove that point. So when we do that, we can actually have our negative 3, which is A. So now we are saying that the A is equal to negative 3. Every time you see this, what you must do is just check that this is true. And how do we check it? You always just check your quadrant whereby your graph is sitting. So let's go to our graph. This is the graph that is given to us. So if you check this graph, for all the points where both x and y are positive, or both x and y are negative, that graph will have the value of A being positive. That means A is greater than 0, right? So which quadrants are those? The quadrant that we find both x and y being positive is this quadrant, and where we find both x and y being negative is this quadrant. So you can see that our graph is not in those two. So that means our value of A cannot be positive. Our value of A needs to be negative. So that means that our quadrant that we are dealing with is this quadrant, which is quadrant 2. So this is where we are focusing on, and as well as there. The moment you have it here, just know that your A value is a negative, where we say A is less than 0. right? So every time you see this, just remember that. And if I check my A, I can see that it's a -3. So that means I am correct that my A is on the correct space. So now it means I have my full equation as f of x equals to a -3 divided by x minus 1 minus 2. This is now my full equation of what I have been looking for, right? Now they said again, for which value of x is f of x greater than 0? For which value of x is f of x greater than 0? What does that mean? That means I just have to actually, you don't have to calculate anything. You just have to go to the graph and then you look where f of x is positive or equals to 0. So we come here and say, okay, I have my f of x, this is it. So where is it positive? From where to where? So if you check this graph, you can see that where x itself, or f of x, which is y, remember f of x is this y. So where is it going to be positive or going to be a 0? Where the graph itself, which is the whole thing. So that is from this point, you can see here. Remember this line is line y equals to 0, right? So in this point here is where we are saying it is equals to 0, which is this part, which is this one here, and equals to 0. And then the other part will be going up, which we are saying greater than 0. So please focus on those two because that is what it means there. And make sure that you can answer to that question properly. So because we don't know the value of here, as I said, we need to find that value. And to find that value, I said, we need to find the x-intercept, because that is where the graph and the Cartesian plane intersect at x-axis. Okay. So we're going to use the same equation, but now we know when we are looking for x-intercept, every time we're looking for x-intercept, what do? We let y to be 0. So that means that we are going to have our f of x as 0 equals to -3 divided by x minus 1 minus 2. That's where you will start, and then we're going to move the -2 from the right to the left, but we don't just move, we add 2 both sides. So when you go there and you add your 2, you will see that you have 2 equals a -3 divided by x minus 1, and then we only need x, so that means our restriction for this will be saying that x minus 1 cannot be 0, then that means that x cannot be 1. This is very important for us to put down so we can always just refer to it, okay? Then here it means now we can now multiply by our denominator. So what I am going to do here is to multiply both sides by x minus 1. So let's do that. X minus 1. If I multiply by it, I'm going to multiply by x minus 1 in the bracket, and I have my x minus 1 there, which I'll multiply it here as well. I'm putting the brackets that are not visible because these two need to divide like that, right? So when they divide like that, I can then have my 2x minus 2 equals a -3. Then I don't want anything near x, so I'm going to have 2x equals a -3 plus 2. Then that is 2x equals to a -1. Then I divide both sides by 2. Then that means x equals a -12. And that is proven correct because this is on the negative side of x-axis. So that means this is actually correct. And that means now I have my x-intercept, or where it has to start. Then now when I answer the question where they're saying for which value of x, where f of x will be greater or equals to 0. Now I know that the values will then include the value of x where x is equals to a -1/2. Right. Okay. So that is basically what it is all about. So you can see that what is happening here is that you multiply it until you get to your x-intercept. But now they said equals to. We know that the x there is equals to. Then we are going to then put it in the space where we say x is an element of a -1/2 and up until 1. But then 1 is not included. And -1/2 is included because it is on here. And then when you go check where your +1 is, it is here, which is an asymptote. And then we cannot use a square bracket. We have to use a round bracket for that. A square bracket is the one that is actually included. And that is how, or this is how you respond to this particular question. And make sure that you do it properly and make sure that you get it right. All right. I believe that you guys have seen this and you have understood how you need to deal with this question. This question paper actually is a very nice question paper. You can see how I anticipated to use it all, but due to time we cannot do them all. But I do believe that you guys can go do these questions and ask us many questions. Ask Muskie as well, since it has these question papers which you can go and download and make sure that you can study with them right on your WhatsApp, right? The number is still 072-091-0388. That is the Muskie number. You show me which you can use and make sure that it helps you as you go. But please, as you do all this, remember to go to subscribe in our Muskie TV channel to help you more and notify you whenever we put anything new, as much as notifying you when we release new series such as Crack the Maths Code for the other subject. All right. See you next week, you guys. I love you. Believe in you. Continue on doing what you do. See you next week. Bye.
And now we enter our next exciting chapter with the launch of Maskieverse, an inspiring trio of innovations, our AI-powered learning companion, captivating TV content, and a vibrant playground for interactive learning, and our own dedicated app, all coming together beautifully to deliver learning outcomes through technology. Now we enter our next exciting